Okay, today we're talking about momentum, and the essential question that we're trying to answer is, what are the relationships that contribute to the momentum of moving objects? So momentum is a word you've probably heard before, either in a previous science class or just in common everyday English language. We sometimes use the word momentum. Um, all moving objects have momentum. So momentum has to do with an object's mass and the fact that it's moving. The symbol that we use to represent the variable momentum is actually an uppercase P or a large P. That probably doesn't make much sense because it doesn't match the first letter of the word, but it's just one of those funny ones that we're going to have to know. The units on momentum are kilograms, meters per second, and we will see when we look at the momentum equation where those units actually come from. So let's look at some examples. Here are some objects that have a large momenta. So a football player has a pretty large momentum. A locomotive or an engine on a train has an even larger momentum. And a comet, as it's going through space, it has a large mass and it's traveling really fast, so it has a large momentum. On the other end, a group of objects that may have a small momenta could be like a toddler on a bike, a mouse running on a little hamster or mouse wheel, and something like this little pea. Though if the little pea guy is just sitting there, he actually has no momentum at all, because in order to have momentum you have to be moving. So what are the variables that impact momentum? We've talked in this class about how there are only a few key variables that make up all other variables, and this will become clear with momentum as well. So one of the variables that impacts momentum is an object's mass. The bigger the mass of an object, the bigger the momentum that object has. And there's actually a linear relationship between the momentum of an object and the mass that it has. The other variable that impacts momentum is velocity. So the larger the velocity, the larger the momentum. So there's also a linear relationship between momentum and velocity. As velocity gets larger, momentum gets larger. So now that we know that there's a linear relationship between momentum and mass, and there's also a linear relationship between momentum and velocity, we should be able to come up with the actual equation for how to calculate momentum. So pause the video for a second and see if you can come up with this formula on your own. Okay, so hopefully what you got when you tried to put these three things together was that momentum equals mass times velocity. So you can see here that there are two linear relationships represented by this equation. The relationship between mass and momentum, and the one between velocity and momentum. There are no inverse relationships in here because you don't see anything on the denominator anywhere. In terms of units, we know that the units for momentum are kilograms times meters per second because the units on mass are kilograms and the units on velocity are meters per second. So nothing cancels out. They all stay right there. So let's look at some trends in momentum. One common misconception about momentum is that you can't have a negative momentum, and this isn't true. So because momentum depends on direction of motion, meaning your velocity in a particular direction, you can have a positive or a negative momentum. Okay, it strictly depends on which direction you're heading as you speed along. So it is possible to have both positive and negative momentum. Another thing is that both mass and velocity impact momentum equally. So let's look at this in terms of kind of a scale here where we have things that will get a large momentum on the left-hand side of our screen all the way down to no momentum on the right-hand side. So if we have a large mass and a large velocity, that's going to end up giving us a large momentum. A medium momentum can be created in a couple different ways. You could have a medium mass and a medium velocity. You could have a tiny mass and a large velocity, or you could have a big mass and a small velocity. So those letters, the size of those letters are representing the size of the variable. A low momentum could be created with a small mass and a small velocity. And when we talk about an object having no momentum, we're going to assume that all our objects have some sort of mass to them, but whether it's a small mass object or a large mass object, to have no momentum, it means they have no velocity or zero velocity, so they're not moving at all. Okay, so to summarize, what are the relationships and variables that contribute to the momentum of moving objects? We've talked about mass and velocity and how they influence an object's momentum. So take a few minutes to fill out the graphic organizer and try and answer some of those extension questions after you finish up your notes.